Example 5.3a. A transportation company is considering whether to purchase Type S or Type R tires for its fleet of trucks. To evaluate the difference in these two types of tires, the company has conducted a test using 15 tires of each type. Each tire is tested on traveling distance in a controlled environment until it wears out. The results are as follows. You have two samples here, Type S tire and Type R tires. So these two type of tires is independent, saling tidak bergantung. Okay, and then you have the average. Here is sample of 15 tires. So the sample size we get N here for Type S is 15 and for Type R is also 15. So based on this sample, we get the average. So here is X bar because of sample, and we get the variance S square because of the sample. Assuming normal distribution with unequal population variance. One information here. Construct a 99% confidence interval for the difference between two population mean. So mu1 minus mu2 of the lifespan of two tires. So based on the equation, extract all the information. We know that sample size is 15. Average Type R, average Type S, variance Type R, and variance Type S, and unequal population variance sigma 1 square not equals to sigma 2 square. So this one is important for us to choose the formula. So which formula that you want to use? Okay, your sample size is 15, means that n less than 30. And you have sigma 1 square not equals to sigma 2 square. If you look at your formula, we have 5 formula for mu1 minus mu2. We cannot use formula number 1 because of sigma is unknown. You cannot use formula number 2 because n is less than 30. So we use the third formula. So what is the formula? The formula is here. This one. This is the formula. Okay, you have the x bar value just now. We have the x bar value, we have the s, we have the n. Now you have to find this. T alpha over 2 nu. The formula for this nu is this one. Look at your stat table. You have this formula. Substitute all the values. Press your calculator. You will get the nu is around 27 point something. You have to round it down, so your nu is 27. Alpha is 0.005. Okay, so you look at your stat table, you will get this one. Substitute all the values. Okay, and then you will get this is your lower boundary, this is your upper boundary. And don't forget the unit. And last, you need to interpret. Okay, that's all for the example 5.3a. Alright, how to solve exercise 5.5a. Based on a study, a random sample of 31 women of normal weight missed an average 3.4 days of work with a standard deviation 2.5 days. Compared to an average 5.2 days with a standard deviation 3.6 days from a random sample 31 women who were considered overweight. So from the first sentence, there are two information here. First, woman of normal weight, and second one is overweight. So you have sample 1 normal weight and you have sample 2 overweight. Okay, look at here, 31 and 31. Sample size normal weight is 31. Sample size overweight is also 31. And you have here average 3.4. So x bar is 3.4. Average 5.2. So here is 5.2. Standard deviation. Standard deviation. So S here is 2.5, as here is 3.6. Okay, assuming normal population with equal population variance means that sigma 1 square is equals to sigma 2 square. Overweight and normal weight. So mu overweight minus mu normal weight. Overweight will be your sample 1, normal weight will be your sample 2. So, normal weight is sample 2, overweight is sample 1. Overweight minus normal weight. Okay, confidence level 93%, alpha is 0.07, alpha over 2 is 0.035. Okay, that's all the information that we have. Which formula you want to use? So look at your formula again. Is there any sigma square? No. So you cannot use formula number 1. Right. Here, the information assuming equal variance. So you cannot use unequal. You cannot use unequal. So it's either this one or this one. Your sample size is more than 30. So you cannot use this formula. So the formula is this one. Right. So we write down the formula. The formula is x bar 1 minus x bar 2 plus minus z alpha over 2 sp 1 over n1 plus 1 over n2. Okay, check one by one. You have x bar, you have n, you don't have this one, z alpha over 2. So here z 0.035 is equals to 1.8119. Okay, next, you don't have SP. So look at here, the formula for SP. Ta-da! This is the formula for SP. Okay, SP is equals to n1 minus 1 times s1 square plus n2 minus 1 times s2 square divided by n1 plus n2 minus 2 square root. Substitute all the information. n1 is 31 minus 1 s1 square 2.5 square plus 31 minus 1 times 3.6 square divided by 31 plus 31 minus 2 and then square root. Press your calculator correctly. Do not make careless mistake. You will get the SP equals to 3.0992. Make sure you press your calculator correctly. So now you have Z alpha, you have the SP. Substitute all into the formula. X bar 1 is 5.2 minus X bar 2 is 3.4 plus minus 1.8119 times SP 3.0992 times square root 1 over 31 plus 1 over 31. Okay, press your calculator correctly. Make sure you do this one first. Okay, you will get your lower boundary is 0.3737 and the upper boundary is 3.2263 days. So because of this, we have to change into this. 0.3737 means that 1 day, 3.2263 2263 means that 4. Okay, lastly, interpret. We are 93% confident that the difference between the population of missed workday among the overweight and normal weight women. Okay, copy from question. That the difference between population mean of missed work days among overweight and normal weight women lies between 1 and 4 days. That's it for exercise 5.5. Alright, last example, example 5.4a. Two groups of students are being compared on their final exam. Marks 2 group. You will have 2 samples. A random sample of 12 students from the first group has a mean 35% with standard deviation 4%. From the second group, 10 students, mean 81%, standard deviation 5%. Assuming normal population with equal variance means that sigma 1 square equals to sigma 2 square. Determine a 90% confidence interval. So confidence level is 90% for the difference between the population mean. So from the question we know that equal variance and the alpha is 0.1, alpha over 2 0.05. Okay, which formula that you want to use? Can we use formula number 1? No, because you don't have the sigma. Can we use formula number 2 and number 3? Cannot, because of this equal variance. So you have formula number 4 or formula number 5. Because of the n is less than 30, you have to use formula number 5. So this is the information that you have. N x bar s. Okay, so which formula? This formula. Formula number 5. Okay, formula number 5. You have your x bar, you have your n. You have the T alpha just now, and you don't have the SP. So the formula for SP here, substitute all information, you get the SP 4.4777. Substitute all information, you will get this lower boundary and the upper boundary. And lastly, you need to interpret. Okay, that's it for independent sample.